All right, I think that we are recording. Let me also start taking notes. And hi, how are you, Moein?
Hello, how are you? I'm doing fine. How are you?
Doing good as well. So first things first, we are trying a new recording environment on Google Meet. So because Zoom actually gave us lots of struggles the previous times that we recorded, we are shifting gears towards another environment. Hopefully this one ends up being better. It also provides a couple of nice functionalities for transcribing and captioning the meeting. So hopefully that would end up being easier for our audience as well. The second thing is that we are away from at least I am away from my routine recording environment. So that's the reason for the new dress code, the new background image, and all this stuff. But hopefully this one also end up being good.
Yeah.
So yeah, Moin, do you have anything to say in the beginning, or shall we jump into it?
No, I think you can start with the first topic you wanted to mention,
Okay,
and then we will
perfect.
change gears in the
Yeah, thank you.
middle. Yeah.
So it's almost a month since the last time that we met, and as usual, many different things happened throughout this month. Lots of new models came in. OpenAI released a new family of models, and I believe a new model came out of what was that? Quen as well. The Quen family of models, Quen 3 models were released as well. So lots of things like that. But I guess you and I are kind of past that checkpoint that we go through each of these models in detail and talk about those unless there is something very specific that might be related to medicine or something huge. I don't think that something like that happened. So let's put that aside, and I'm going to start talking about a paper that I wanted to actually discuss the last time that we met, but unfortunately we ran out of time, and I didn't want to discuss it in haste, so I postponed that for today. Yet still, I believe this is something that it might be worth talking about a little bit. So let me share my screen and go through everything. So I'm going to share my current window. Yeah, there we go. And Moin, please let me know if you are seeing this.
Yes. Yeah.
Okay, all right. So this is the paper that I wanted to introduce the last time. It came out around. I mean, I guess the final version is about to come out in June 2025, but the paper was released about a month ago, and it's an open access paper, so everybody should have access to this one. And it is a single author paper by Dr. Felix Nensa, which is an AI scientist and radiologist from Germany, and he's also a very good researcher in radiology AI. So I was just reading a little bit about his background, and he definitely looks like to be an expert in the field. Even though regardless of his expertise, these kind of papers are inevitably kind of expert opinions. Yet still, so we are hearing an opinion from someone who is already very active in the field, and that at least gives me some reassurance that we should listen to what he has to offer. And the reason that this paper caught my mind, caught my eyes, to be honest with you, was that even though this is also one of the millions of papers or one of the millions of social media posts that come out every day and talk about the future of radiology and how it is going to change in light of AI, this one has kind of a different approach, and it's kind of offering a proactive role for radiologists. And rather than talking about how radiology could be changed or how radiology could be replaced by AI and radiologists are about to lose their jobs or things like that, it is thinking about how we can shape the future for radiology. And to be honest, he is kind of talking about all these issues in a way that is really interesting. So I'm going to read you some of the notes that I took from this article. This is a very long article, of course, if you want to go through that. Maybe a good uh, food of thought for Notebook LM, to just summarize it for you. Or if you like, just put it on in Gemini or any of these chatbots, and they will give you some quick summaries. Because I want to discuss this with you, Moein, I don't want to, take too much time going through all the details, but I kind of captured 4 or 5 points about this paper that I want to read for you. And this is just from a note that I have on my paper. Uh, I think that you are still seeing the paper on the website, right? If I'm
Yes.
okay. So I'm just reading from my own notes now. So the very first thing that this paper offers is an evolution for the radiologist role. So it is saying that, the core role of radiologist is kind of shifting from primarily interpreting images to becoming an information specialist, or as the author mentions, a diagnostic orchestrator. And he's saying that, radiologists from this point onwards, or maybe from a couple of years ahead, should synthesize insights from the diverse multimodal data sources that they see for their patients. And this is not only imaging, but also genomics data, lab data, and even the clinical notes that they receive from other physicians. So the point is that so far, radiologists have only been focused on imaging data and interpreting them. The thing that is going to happen from this point onwards is that we are going to face multimodal data. And this actually leads me to the next point I wanted to say, that the future of AI in radiology lies in multimodal systems that integrate imaging data with various non-imaging inputs. And these systems mirror how radiologists already use clinical context and are expected to offer superior diagnostic accuracy in the new era that is to come. Now, basically, we need to move towards understanding not only the imaging data, but also the genomic data, but also something that stands maybe on the intersection of radiology and pathology, and maybe even on the intersection of all of these and the clinical bedside data. Now, with all this said, there definitely is an urgent need for new skills and training, because the traditional radiology training is only focused on image interpretation, and this is not going to be sufficient anymore. So we need to expand that to areas like data science, bioinformatics, genomics, and systems biology, along with the skills in managing uncertainty and interdisciplinary collaboration. And if we do so, we are already very well positioned to lead AI integration, because we have already interacted for a long time with digitalized data, for example, in the format of DICOMs. And we have had a central role in patient diagnostics, including in multidisciplinary boards that happen on the hospitals. And we do have a testing ground for AI. So we really are well suited to lead this change. The point is that we have a choice. We can either lead the change, or we can either be the one who changes at the end. And this proactive adaptation is the main point that this author is actually offering here, saying that, maybe stop all that nonsense discussions about whether or not that we are going to be replaced, and instead start focusing on what is the future that is coming on and how we can train the new generation of radiologists in a way that they can continue to play a significant role in clinical care. And I really like this kind of idea. And I believe that this is the kind of thought, that this is the kind of approach that we need to see more often from people who are active in the field, rather than those very pessimistic approaches that we are going to be replaced, we are going to change. Yes, nobody can predict whether or not AI is eventually going to change completely eradicate the current practice of radiology. I personally think that one year in history, this is going to come. I'm not quite sure if this is going to be very close or this is going to be very far away from now, but this is going to happen eventually. And when that happens, the question is, what is going to be radiology afterwards? Is that going to be nothing, vanish? Basically, we don't need this specialty anymore, or is that going to be something evolved, something new, something more capable? And that is what this author is saying. So I'm not very obsessed with the exact future that he is envisioning, and this exact kind of a skill set that he believes radiologists should have from now on. But I do believe in this kind of thinking, and I do believe in the interdisciplinary nature of whatever a radiologist needs to do in the future, even if we don't agree on the specifics that Dr. Nensa is mentioning here.
Yeah.
So I stop here. I would like to hear your thoughts. And I think I can even stop sharing the screen now so that you and I can see each other without seeing infinite mirrors. But yeah, that's what really caught my eyes for the past 1 month. And I'm curious to see what you think about that.
Yeah, thanks for sharing it. It was a very inspiring topic to just get started on reading it and thinking about the future he was presenting for the future of medicine and AI. And when you were mentioning the multimodality nature of the data around the patients in the hospitals, I was thinking that we usually used to think about the future of pathology, future of radiology, the future of subspecialties, but we maybe sometimes we forget that the whole medicine is going to be changed, and maybe that changed medicine subspecialties are not going to be radiology, pathology, or other things. Maybe some of these things get merged, or maybe the roles are going to be different now. I'm just saying that when the whole field is AI first, AI is at the core of medicine. Maybe in that future, the way we design the subspecialties, the roles of the
Yeah,
physicians get
everything.
just totally different. I mean, uh, maybe radiologists now tend to work on positions that are related to AI and some form of imaging, not exactly radiology imaging, but on positions where most of the data around the patients gets merged into some model, and then imaging is just one of them.
Yeah,
And when you think about it in this picture, that most of the data around the patients, like the labs, the notes, maybe some form of conversation, human conversation with physicians that gets digitalized. The genomes are all digital and available for each patient.
yep,
In that future, imaging is just another modality. So maybe it's not that just a very different
yep.
kind of entity that needs its own specialty. And in that scenario, the whole medical education, the roles, the positions will be changed. And I think it's not very. I'm not sure how many years, but I don't think that's very far fetched.
Hmm.
And maybe we will see this in our lifetimes, that this
Yeah,
whole picture is going to be totally different. And I totally agree that this multimodality approach is probably the best and most performing approach that can help with diagnosis, with treatment, with anything that is personalized, that is for each patient, customizable for each of the patients. And yeah, in that scenario, I think radiology as we know it in these days is going to be very different.
I agree.
And just another kind of like skill beside other modalities that help to know the patient better. And
Yeah.
this was something that came to my mind. Maybe it's the first time I'm thinking of it in this way, but yeah, it's a little bit futuristic. But I think if AI is going to be at the core of medicine, not just as an additive, not just as a tool that augments each of the subspecialties, in that case, yeah, the whole roles and the whole picture is going to be different.
Exactly. So I think, as you were saying, and I was just reading this paper and thinking about that, maybe the only a still visible line that we can draw in that future between the different types of data is the data that comes from the bedside. When you see your patient, take a history and examine them. And basically every other kind of data that is kind of paraclinical data that comes from the labs, comes from the genomics, comes from the pathology, imaging, all of those are kind of very similar and entangled with each other. And the fact that we have been interpreting them independently by different specialists nowadays, that solely means that we have not been leveraging the entire spectrum of information that we could get from that data. Even
Exactly.
that border between clinic bedside and non-bedside data could also become fade out as we go forward, because we have nowadays all these AI applications that can take note of your entire visit with the patient, write them for you, and maybe even before you come back to your desk, all that data is now sitting next to your imaging data, pathology data, and then your only job as a physician, let's put aside the specialty you're in for one moment. As a physician, your entire job is to interpret the vast amount of data that is in front of you. And now, if we are just drawing borders between ourselves and putting each other into different silos and label them with one specialty or another, that's our problem. And we need to look at everything very differently. And yes, I agree with him that the very first step might be to at least try to get those specialties that don't have that much of significant difference with each other become closer. Pathology and radiology in the first place, and genomics maybe in second place. These kind of specialties need to stay close to each other. Maybe the first step is to have their physical departments to be next to each other, to have their attendings and faculties and to researchers to talk with each other more often, and try to promote interdisciplinary research between them, so that one checkpoint in future we can actually merge them into each other.
Mhm.
I'm not sure how much. I'm pretty sure that this is going to see a huge resistance from everyone who is in these fields and everyone who is not that much optimistic about such future. And people usually tend to super specialize themselves, because that gives them this false feeling of security that now you're safe here. The thing is that it is not going to work. And if we don't do it ourselves, probably Google and these big tech companies are going to do it for us one day. And then, if I am a patient and I see that this is a very well-known hospital and this is Google, and, yes, for a probably very significant amount of time, I'm going to trust more in this hospital because that's the system that I'm used to. But one way or another, I'm going to figure out that the output of that system is going to be better. These big tech companies that might start coming up with their own healthcare system one way or another. And this is a very complicated picture. I'm not sure how it's going to shape out in the future, but something is going to happen for sure.
Yeah, and many of the topics around how AI is going to augment X and Y reminds me of the one of the sayings of Henry Ford, I think, when he said that the general approach to just making what I wanted to make, what I had in mind, was just to build a faster horse, maybe. But no one thought how you can make something totally different, which not only is outperforms horses, but can do lots of other things, and it doesn't have to be like a horse.
Yeah.
And here we, when we talk about how AI is going to help with X and Y, we think how it can help with the process that is going and that is being done already, and how it can fasten it, how it can improve it. And it's really difficult, basically, to think about a whole different future where AI is the first stepping stone
Yeah.
that the rest of that specialty, that field, is going to be built from that point on. And if you think about medicine in this way, we don't just want to improve each of the subspecialties, each of the tasks. Maybe we need to first put the AI, and by AI I mean the whole data that we can analyze for each of the patients, and the models that can analyze these integrated picture of the patient, and then see, okay, in this world that we have the compute, which is a question, do we have that compute? And the models that can analyze this vast amount of data, what would medicine look like, and what would be the role of the physicians in that world?
Exactly.
And I think that also applies to many of the technical aspects of AI. Like people are asking questions like, do AI models think like humans? And I think that is one of the uh, most wrong questions. It doesn't need to think
Human.
like us.
Yeah.
Maybe it does its own thinking, or it does nothing, but it outperforms all of us, and we don't care how
Yeah.
it
Definitely.
outperforms us. Yeah.
Yes.
And I think the same approach and the same kind of line of questioning also applies to whatever else AI is going to be deployed in. And yeah, I think
I agree.
it's going to be the final picture. I think it would be much more complicated than uh, how AI can improve this thing 10% better or something like that.
Yeah. And again, I agree that this is going to be super complicated. I think that we do not need to wait for that picture to happen. We can actually draw that picture. And I think this is very, very informative and very mind brightening approach, much better than just sitting and waiting and counting seconds for when we are going to vanish, which unfortunately is something that I hear a lot from physicians, not only in radiology, but also in other disciplines that I tend to interact with. And they ask this question: how longer do we have time? And this is a very wrong question to ask. The question is not about how much more time you have. The question is that what you are going to do in the time that you have before things become a chaos in the world of medicine. And if you're proactive, if you plan for it, maybe by the time that everything becomes chaotic, then people look for established plan, and then you have something to offer, and then you could lead that change towards the direction that you benefit the most from and your patients benefit the most from. Anyhow,
And,
so yeah, please.
and yeah, just as a final point, if we look past the maybe 8-10 years from when the first AI application, like 2015, 2018, in medicine were making headlines, we can see that the changes we are seeing in the workflows in the hospitals, or maybe in the private sector where AI is being used to analyze images, at least most of the examples, or all of the examples that come to my mind, include physicians in their teams that have made those changes and used those technologies and integrated those tools into their daily routines as a physician. It wasn't something that's brought into the pipelines by some aliens, by some maybe only computer scientists can do thing. And I think that is another proof that if a change is going to be made in the field, it's going to be built by the physicians themselves or interdisciplinary teams that include physicians. So physicians have the possibility and responsibility to make those changes, and it's not something that is doing by some outside factor only.
That's true. That's very true. That's very true. All right, so let's wait and see what comes out of that. But this is a very nice read for people who are interested. You can probably go through that and find much better insights than how I shared that and Moein said about it. Just read the paper. And with that, I think we can move to the next topic. Moein, do you want to go ahead? Do you have anything big to talk about?
Yeah, well, that's a kind of like a big change in gears. Do you have other topics that you want to cover that is more kind of like
more relevant to this one?
Yeah.
Okay, let me take a quick look at that. Now, to be honest, that was the only main paper that I had, which was kind of related to medicine. I have another paper that it's not a bad paper, but not that much critical to share in the beginning. The next ones, I have a collection of small things to mention, a couple of courses, a couple of nice blog posts and tools and things like that. So I think that maybe I have one more relatively larger topic to discuss, but definitely not related to this one. So feel free to switch gears if you like.
Yeah, okay. So let me see which one to start with. Yeah, and most of the topics I wanted to mention today are short kind of introduction to some cool new thing that came up. But I thought we mentioned Google in our talks about the technology and how AI is going to change medicine. So let me share a good blog post I saw in the praise of how Google is doing its good engineering in all fronts of AI. So let me start there. If I can find it, yes, here. It's a bit kind of like, am I
Yep, you're sharing.
the next one? Yep. Yes, okay. Now, this is the blog post. Google is winning on every AI front. The text is very bullish on Google, so and it's a bit maybe exaggerating in some aspects. And these are the opinions of the author, but most of that is just facts and truths that we can see clearly and more clearly every day. And as we let me give some background on how this LLM war began in, I think, 2022 or 2023 with the rise of ChatGPT. For the few first months, we only had OpenAI with the successful ChatGPT application and the UI that was kind of mesmerizing everyone's mind at the moment. And very slowly we saw other competitors in the scene like Anthropic, and then Google came with its Gemini line of models, then broke it into the main Gemini family and the Gemma, which were the smaller models that are open source and could be run locally, and much more manageable in terms of size and compute. And also other competitors like Claude came into the scene and kind of made this whole competition much more difficult for OpenAI, which started it basically. But we all know that the technology that OpenAI was investing in and making this whole ChatGPT out of was basically transformers, which was
Mm.
uh, the the seminal paper by
Google.
researchers at Google
Yeah.
at 2017. And from then on, it was just the game of scaling that architecture to be trained on trillions of tokens and to train billions of parameters of a model to make some high quality model that can interact with humans very well. And we should give credit to OpenAI because of kind of like popularizing this idea that yes, LLMs work and people can chat with them and get help from them, and also for the introduction of the idea of the RLHF, the reinforcement learning from human feedback, that help these answers to be much more liked by humans and much more feeling human-like, basically, because of how this RL was performed. But as we are seeing today, Google is back to the game, to basically at the front of every sort of benchmark or frontier that you can imagine.
Mhm.
And I think for the AI developers, that was a good feeling to see Google
Very.
being back,
Yeah.
because they were open about the research from the start. Like unlike other competitors, basically starting with OpenAI, who closed their sharing their science, Google started the whole game and shared as much as they could. I think even these days they do not share as much as they were sharing before, but
Yeah.
at least they contributed a lot to what we are seeing today
Yeah.
in terms of AI technology. So
But
um,
but as you and I were saying, even if we just ignore the fact that they have already open sourced and talked about their research, the simple fact that they are providing access to their top tier models with very generous free tiers and with almost free of charge access to their Gemini 2.5 Pro and Google Studio, and as you were saying on the Gemini app, I guess all of these things are themselves very valuable and things that we don't see with OpenAI or Anthropic or any other company out there. So kudos to them.
yeah, and that's a very good point. And also, I think it was also another thing that could be praised about Google is that they have made they have access to such a powerful infrastructure that can give all these features for free or almost for free.
Yeah,
And yeah, that is another huge strategic move that the
yeah,
founders, the managers have been able to perform to to outperform basically OpenAI and other competitors. So this blog post is basically about what we already touched upon here, and it goes to some story about how the whole game started and what are the big competitors at the moment. And I think it was written and released after the introduction of the Gemini 2.5 Pro, which was basically the game changer, or where we could say, okay, Google is back at the top of the
yeah,
leaderboards of LLMs. Before that, it was just a tight kind of competition between Google and OpenAI. But after that, it was clear for everyone that it's outperforming whatever we had already, and it was perfect at coding, solving very complex coding problems that even Claude 3.7 thinking
yeah,
couldn't perform at that level. And yeah, here you can see some of the benchmarks on how good Gemini 2.5 Pro is performing at, and it's basically outperforming any of the previous competitors. There are links to some very good high quality
Yeah.
blog posts on comparing Gemini last model with the Claude last model on coding examples, and this Ruby Cube example is from that. And yeah, and here is also mentioning that this is this power with that huge context window makes it great for coding, and also given this power and this big context window, the prices are much lower than the other competitors. And this is for Gemini 2.5 Pro. If you consider 2.5 Flash, which was released a week, I think, after the Pro version, that is the most powerful model in the efficient regime of the benchmarks that I will show you the charts a bit further. Yeah, here, Gemini 2.5 Flash launching soon, which is launched now, is Gemini 2.5 Pro's little brother. It's just as amazing, but for a different reason. And that is being extremely fast and extremely cheap, even cheaper than the DeepSeek, which was the headlines of the newsletters and anywhere, and it was making some threats kind of like to the US technology. But yeah, with Google being bad at the game, the prices are even lower than the DeepSeek R1 family. So you can see the Gemini 2.0 Flash, and this is not 2.5, this is the charts for 2.0, because at the moment the other model was not released. And as you can see, it was much cheaper than the competitors. And also, alongside these high performance and world-class kind of like models, Google has its own open source models called the Gemma family, which OpenAI basically doesn't have any
Open source.
launch in their products for. And also, I think other competitors don't come up with these lines of manageable models. They are either totally open source, like Llama, like DeepSeek, or totally closed source, like Claude or OpenAI. But Google is handling both worlds very good, I think. It has its closed models, the Gemini family, and also the open source lightweight models like Gemma. And is light, we call them lightweight, but they also are as big as 27 billion parameters. But basically, they could be run on a single GPU, which is crazy. And it gives a lot of power. And also, if I forgot, please remind me to also look at the performance of the Gemma family on a separate blog post, and on the Ollama extension that can the audience here install on their own laptops and just run a 4 billion parameter model on a 8 gigabyte RAM machine. It's crazy. Yeah, and this was the plot. The x-axis is the pricing, and as you see, this is a decreasing axis. And the y-axis is the performance on the LMSys. And that is the LLM Arena ELO scores, basically. And as you see, at each of the pricing intervals, pricing buckets, basically, the Gemini family is the outperforming of all the other models, which is, I mean, a very difficult achievement to be better than all the other competitors at the same time with much lower prices. And I think that the big winner for the Google is its investment in the infrastructure that made it just possible to offer these high quality models for much lower prices, and also to having access to lots of other sources of income, that its business is not dependent on the AI business only. I mean, on the LLM business only. It is, AI is everywhere at Google, even at the simple Google search is using AI. But unlike Anthropic, unlike OpenAI, its business is not dependent on the LLMs, which makes it much more kind of like risk taking, because they say, okay, we tried whatever, and if they even fail at a release or two, they know that they will have the funding for yet another experiment, yet another family of models. And I think we saw those failures a few months back, a few maybe years back, when they couldn't compete with OpenAI models. But they changed, they improved, and they just spent more money to making better teams, making better models, and yeah, here we are. And yeah, and also Google is also applying AI and generative AI on other frontiers, on other modalities like
Yeah.
images and videos. I've still not used the VEO, the VEO. I'm not sure how that's
I
pronounced.
just watched demos of that, but the demos looked very nice. The demos looked
Mhm.
very nice, but I have not yet played with that myself.
Yeah, and also to be honest, I've recently tried Sora for video generation, and I was kind of like, mm,
Disappointed.
yeah, disappointed. And I think the
Yeah.
advertisements for when it was released was very overconfident, kind of like on their technology, or very cherry picked
Mhm.
examples were shown. When I was trying simple, um, basically image to video generations, so I was uploading an image and wrote some storyline on how to
Yeah.
change it and how the frames should change to make a 5-second video. It wasn't following the
Yeah.
instructions very well, and there were some glitches, and yeah,
Yeah.
kind of
My
like,
experience was kind of similar as well. I once played with that. Not that much satisfying, at least not as good as the demos and all that marketing that
exactly.
AI did. Yeah.
Those examples and demos set the expectation bar very high for me, and I was like, okay, whatever I type in, I get a very plausible video out of it, but it was not like that. I think it needs probably lots of fine-tuned prompting
Yeah.
and uh, good skills on how to make a video, maybe for professionals, for artists, but for some layperson like me in making videos, it was just very difficult to make something good out of it. But yet, Google has its own line of image generation, video generation models, and even music generation models that are also available for free, but mostly developer-faced UIs and websites. This is not something very popularized like Sora or the image generation of the OpenAI models. And it also provides deep research feature for free, or at least
Yeah.
with some limit for free, which is the paid feature in OpenAI. This is the premium feature in OpenAI. You don't have access to deep research for free in OpenAI, but even providing it as a free feature, it shows that the benchmark shows that it's vastly outperforms the OpenAI deep research feature, which is also another interesting fact about it. They also recently introduced the agent-to-agent protocol, which is a complementary and compatible MCP protocol thing. I haven't worked with it directly, but this is something that is going to
Huge.
be,
Yeah.
I think, yeah,
Yeah.
very popularized and used by developers very soon. And it was also a very good move, I think, by um, Google and OpenAI to just agree that the MCP protocol is a good thing, and most of them, or maybe all of them, integrated that into their LLMs, which was a good point of agreement in all of these different benchmarks, different, I don't know, protocols, different naming conventions that each of these companies were doing. And this introduction of this MCP and it's being used by most of the competitors in this scene just showed us all that there is some convergence point, that maybe all these models could be in the same ecosystem working with each other, and they don't just live in their own islands. And another good point, which I really liked and agree on, is that the papers by DeepMind and Google are still the high quality and the basically the award-winning papers in the top tier kind of like journals and conferences. This is something that you rarely see from OpenAI these days. OpenAI papers were one of my favorites in back in 2020, 2021, but it's many months as that I haven't read a good OpenAI paper, or seen a good OpenAI paper recently. I remember reading the Clip paper, the Dolly papers, and really enjoying the lots of the creative points they were mentioning in there. But
Yeah,
these days, I'm not seeing much research output from their teams. They're mostly keeping it private because it's just business.
exactly.
And yeah, so this was all for, yeah, and here is another shocking fact about Google, is that the Google and YouTube, which are the first and second in total search traffic, get a combined 50% of the total traffic share in the world, which is, I mean, that is what gives Google the confidence that, okay, their businesses are going to be fine, whatever probably they do,
Yeah,
and they can just spend so much money on whatever experiment that they can run, and to build high quality infrastructures. And that is a very difficult moat to break for some companies like OpenAI, because their whole existence, their whole business is around LLMs, and they don't have kind of other complementary businesses that leverage from this technology. But for Google, it's just like another product, another line of business.
I agree.
And yeah, and by
So,
the way,
yeah,
yeah,
go ahead.
no, just wanted to mention that it is still very impressive that ChatGPT is responsible for 2.33% traffic of the world after these famous applications and
Yeah.
softwares.
And
And this
even
is some,
before X, before
yeah,
X,
therefore, yeah, and this is some application that didn't exist 3 years ago,
mm,
and just in
yeah,
2 years, it's this useful, this
yeah,
popular, and yeah, and this is really, I think, big achievement for
yeah.
OpenAI.
I also saw one similar chart about ChatGPT the very first day that it came out. It was a chart that was comparing how long
Mhm.
it took Instagram versus YouTube, versus all these big kind of platforms to get around 1 million users. And all of those took about 2 or 3 weeks or something like that. And ChatGPT did that in about 3 days. So yeah, that definitely shows how AI is actually penetrating into every single community. So I want to say something about this entire blog post that you brought up, but one thing that you wanted me to remind you of was to show us the ranking that Gemini has. No, so not the Gemma model has, the open
Yes.
source leader
Yeah.
broad of Gemini.
Thanks for reminding me. And also, a finishing point here is about the Google being also a hardware company, which I think that is one thing that makes Google very different to all the other competitors. And by being a hardware company, I mean, Google is making its own chips, the TPUs that are around for, I don't know, when the first ones came, but I think it was at least 5 or maybe 10 years ago.
Mhm,
And they recently introduced their latest version of TPU, the seventh version, called Ironwood.
mhm.
Just to give you some idea about how good this model is, I'm not sure if my, no, I think I need to reshare my
Your
screen
screen
to give
shared.
you
I
this
see
one.
that.
Yeah, I'm sharing. I think a
Oh, you're
tab,
sharing
not
another
my
window. Okay. Okay.
entire Chrome. Yeah, I need to change that. Um, Yes, I think this will solve this. Yeah, this is the blog post by Google introducing their Ironwood TPUs. I just wanted to show this plot here to give you some idea of how better this new generation is compared to the last one. And this is the peak performance, and this is uh, 3,600 times higher than the first or the second generation of TPUs. And as you
Yeah,
see, 10 times better than the previous generation, which is, uh, I think, a huge leap in technology that they were able to put in these new chips. And this is happening while all the other companies are kind of competing to get the first GPUs out of NVIDIA and making deals on who gets the first chips when. But Google, by relying on TPUs, is playing a whole different game. And these
yeah,
TPUs are, as you see in the title, are for inference. The first Google TPU for the age of inference. So it's very interesting that they probably knew that this phase in AI would come
it's going to
probably
come.
maybe two
Yeah,
years ago, that
yeah,
they were building towards this new generation. And now it makes them in the best spot compared to other competitors
I agree.
to just run these TPUs for inference for their biggest models and don't care about the costs because they build the chips, they have their secure sources of income from their other lines, and yeah, this is how they are outperforming others on every basically front in AI. So I pause a little bit here if you want to add
No, very,
uh,
very insightful
and,
discussion. Yeah, thank you. Thank you. Very insightful discussion. Maybe just one small point to add. And that is my kind of personal take on how Google did this. And if you remember on the very first days that Google tried to enter the field of AI, they had some very big, kind of embarrassing failures. I mean, they started with, I believe, a model which was titled BART on those days. I mean,
yes.
around the same time that ChatGPT came out. And you probably remember how much poor performing that model was. I mean, it definitely had some sort of very weird biases in the data that it was trained. And I believe what happened after those failures was that Google paused for a second and tried to reflect on what is happening and why it is falling behind uh, OpenAI and those other much newer startups, much smaller, much less
Mm.
financed startups. And I believe they finally found the main reason. So one thing that is happening now, and you can see it in OpenAI, how OpenAI behaves to some extent, how uh, Anthropic behaves, and definitely Meta behaves, is that these companies are kind of very reactive to how each other is behaving and how even companies out of the US are behaving. So, for example, the DeepSeek comes, and immediately after they release a model, you see that OpenAI releases a new model just to make
Mm.
sure that they are not losing their share of the market. Or, for example, if Anthropic is releasing something, then OpenAI is forced to release something. You kind of, as a user, or maybe as a little bit of developer type of user who is following this kind of AI news, you feel like that OpenAI is just trying to stay on top of the market, on top of the news, and because of doing so, they need to just push as fast as possible to production. And that was the exact same mistake that Google made in the beginning. And the thing is that people are going to be much more cruel towards a company like Google if they make such mistakes compared to OpenAI. Because at the end of the day, nobody is expecting a 3-year-old startup, regardless of how much revenue they have and how much attraction they raise, to at least behave as maturely as a company like Google does. Now, so they paused on that checkpoint and they realized that, okay, we need to maybe endorse a different strategy. And that is what they finally did. Nowadays, you don't expect the Gemini family of models to come up with a new model every day, to come up with a new, I don't know, basically a new public event every 2 weeks to just announce a new model. Yes, they do have their own kind of events, but they are definitely less frequent than how OpenAI team appear on YouTube every 1 week or every 2 weeks and then introduce something new. So I think that they are now focusing more towards building very reliable, very mature products that even if they are not on top of every single technology that people introduce every day on the internet, they still are being referred to by people who are looking for that level of maturity. So I think that this, in addition to the infrastructure that the Google has, as you mentioned, and the amount of revenue that they have, this is also an important factor that is, keeping Google on the frontier of these AI models and on that very beautiful red curve that you were showing on that plot. This is my personal take on that as well.
Yeah, and that's very true. And based on some conversations on X on Twitter, and the video by Eric Schmidt on YouTube, which was weirdly
Yep.
removed a few days after,
Mm.
I think some of the changes that happened in Google that's led to these final achievements were exactly in the line of being more agile, having um, more performant teams that are not just uh, playing games when they are at the Google office, and they're working very hard on the problem that they're assigned, and being back to the form of the um, like the starts of some startups, that people are motivated and they're working 24/7 kind of like thing, and they're shipping fast. They're okay with some failures with their products, but they make changes very fast. And the amount of, I think, bureaucracy in the processes of internal processes in the Google, I think, is decreased. And probably those first failures were needed to make these final changes. And I can think of books that are going to come in the next months
Yeah,
and maybe years on the lessons that could be learned from these
exactly.
failures and the successes of Google, and how it changed the whole game by being okay at failures, even being a big company and name and brand like Google. And yeah, I think there are basically a lot of lessons in there. And however they did it, they just made out of this whole game very successful, and
Mhm.
they have lots of things to say from now on.
I agree. I agree. But anyhow, very insightful discussion. Thank you. All right.
Thank
Do
you.
you want to?
So yeah, I just a quick mention of the
Mm,
Gemma
yeah.
and also the Ollama, and then I think let me see if what happens if I share the window. I have shared the entire screen and the tabs, but I don't know what happens.
Yeah. So when you share the
Yeah,
window, it's actually going to be a little better because I believe what happens is that then we are not going to see that card
yeah, the
that,
box when
yeah,
we
that
are
box.
talking. Yeah,
Yeah, only
exactly.
appears when you're sharing the entire screen, I believe.
Yes. So this is not basically the introduction of the Gemma tree
Hmm.
family. This is the introduction of the Gemma tree quantized models, which is another very
Yep.
big step
Yep.
that
Yep.
Google made. It was we were used to seeing that these big companies release their models, and we were hoping that maybe someone comes out of GitHub and Twitter and quantizes these models and uploads them somewhere, and then we can use and play with them. But this time, Google team themselves, probably with some collaboration with teams that were doing these sorts of quantizations before, maybe like Hugging Face. I haven't gone through where the collaborators in this project, and they have released their Gemma tree family. They re-released basically
Mhm.
those models, um, the quantized version that requires much less RAM for the machine, and basically you can run a 4 billion parameter model on an 8 gigabytes of RAM. And yeah, this is the blog post, and there are lots of good points here on how the changes were made, how the numeric systems were changed to make this possible. And these models are 4 bits models, so they run on int form numbers, which is crazy. And I don't still know how they do such things. And yeah, as I'm not sure if I have mentioned this. In the Gemma tree family, the 1 billion parameter model is only text, only a text model. The input is only text, but for 4 billion parameter up, it's kind of like a vLLM thing. So it gets both text and images. You can ask it to OCR or read the characters in an image or ask questions about an image, and it's very good. And this surprises me every time that I just drag an image into the terminal of my Mac and then ask Google and ask Gemma 4 billion something about that picture, and it gets it right every time. The images weren't that complicated, or I didn't try to just make it super confused, but those examples that I tried, it was very good at them, and it was clear that it has a very good sense of the images as it has a good sense of text itself. And yeah, lots of as you see, the reduction in the VRAM that is required to run these models compared to the raw models is just huge. And you can download these models easily using Ollama, and all the previous generation of the Gemma 3 models, the non-quantized versions and also the quantized versions, are available. And just by running this command after installing Ollama in your terminal, you have access to an offline LLM that can work with images, that can work with text, and you can ask it maybe some. And one of the use cases these days for this sort of running LLM on a terminal for me is that whenever I want to do something in the terminal, maybe I want to change the DNS of my Wi-Fi, or I want to make a new file and put something in it. I just ask the LLM, could you write a command that I can copy and paste that works, that does this thing, and it works. I mean, like magic.
And then you just create and paste it there.
Yeah, and yeah, these are some benchmarked results, and I think I'm done with the introduction of these new products by Google. So I hand it on to you for now.
Thank you. Yeah, very interesting one. When you were talking about using these AIs in terminal, I also remembered a couple of products that came out and were actually providing these LLM access in the terminal. I do remember a couple of commercial ones that came from Anthropic and from OpenAI. Both of those now provide kind of like cursor-like or Windsurf-like functionalities in terminal as well. And I do remember, unfortunately, I don't remember the exact name, but one a specific terminal application for Mac and Linux that has this kind of built-in AI assistant incorporated. So you basically just type what you want to do in English, and then the AI behind the terminal application does that for you. I hope I remember the name of that. It was like had a W letter in that. Let's see if I can find it. It was
yeah, it was very good to mention that both Anthropic and OpenAI released their products that are some installable kind of like tool in the terminal that is performing a feature like Cursor, that you can talk with it and it just runs the commands in the terminal itself. And yeah, they were very cool. I tried the Anthropic one. I don't remember the name of this new product, but yeah, I tried it and it was cool.
Something like Cloud Code or something like this, I believe.
Yes, I think.
Codex, something like that. I guess for OpenAI, the name was Codex.
Yeah, the Codex I think was for OpenAI.
Yeah, Codex is one for OpenAI. I'm not sure, but I do know that Cloud also came up with something similar. Cloud, oh my God, if I remember the name. Anyhow, but yeah, there are different tools that you could try there. And then you could basically access your terminal and work with that using AI as well. So nice one to just have in mind and have on our radar. Now, let me talk about another topic that I had in mind. Not that long, probably, but I'm going to just share some insights I learned from this. So the idea comes from this blog post. There is this nice one, foundational recommendation systems from Netflix. and I ran into this nice LinkedIn post by David Sauerwein. And this is just a summarization of what this blog post has to offer, which I guess is a very nice summarization. I'm going to come back to that. But for now, let me show you the blog post itself. And the blog post came out of a data science team and Netflix. And it is interesting. Netflix is not one of those companies that you see them that active in AI research. So when they publish something, it kind of raises some attention and people want to understand what they have been working on, because Netflix also has lots of data. And I'm pretty much sure that, like any other company, they have also been thinking of how to use that data for their further benefit and, to make the user interactions better as well. Now, what they did here is actually interesting. They came up with kind of a family of generative models that is very similar to large language models, but they call those personalized recommendation models, or actually foundation models for personalized recommendation. Now, the idea here is very interesting. They say that we thought about how LLMs work, or even large multimodal models work, and how they tokenize words, the entire alphabet, and even some imaging, and how these embedding models work and all that stuff. And instead of using those models for their own purpose, instead of just relying on lingual feedback from their users to understand what they prefer, they basically invented a new tokenization mechanism. They basically invented a new sort of language for their own model. And they said that rather than looking at the likes and dislikes of our users towards the different media that they have been confronted, we relied on their entire interaction. And we thought that, there is really some meaning in how in the sequence of likes and dislikes, and maybe saving to playlist and all playing and things like that the user does in I don't know, maybe 10 minutes box of them interacting with the Netflix applications. So they're saying that that the old-fashioned recommender systems that were mostly borrowing from natural language processing, they were just looking at these different signals like playing, liking, disliking, adding to queue, or things like that very independently. They were not looking at a chain of these interactions. They were looking at each single interaction independent of another. And they had some good results, and definitely the entire recommendation systems that we see nowadays on YouTube and Netflix and all these platforms are based on those body of research. But what Netflix is offering here is that we are missing on many, many insights that we can get out of this. So as I said, they are now looking at these series of interactions that a sample user does as a sentence in which the alphabet consists of letters like playing, maybe saving, maybe liking, maybe disliking, and things like that. And they say that whenever a user comes in and they play a movie, we are going to record the genre of that movie. We are going to record, I don't know, maybe the actors present in that movie, maybe the director of the movie, any different kind of insights that we can get out of the metadata of that movie, as well as the details of the interaction, in what device it happened, in what time it happened, and all of things like that. And then we are going to also get the same sort of data from the next interaction they immediately did, and then from the one afterwards, and so on and so on. And then we are going to look at each of these as corpora of texts. So like, for example, how these large language models embed an entire paragraph. These are going to embed an entire series of interactions. And then the next thing that this blog post, this LinkedIn post also talks about is how they approached token embeddings. And as this author here is saying, unlike LLMs with their single embedding space, interaction events contain heterogeneous details such as the location, the time, the device type, the content, and many different things that basically every single interaction contains. And now they're saying that we actually gave our model the room to embed all this data appropriately. And then afterwards, we trained our model to basically guess the next token, which in the case of Netflix is going to be the next interaction the user is going to make. So say, for example, we are going to give the model these first 4 interactions and ask them what would be the next movie that the user is going to play if they keep on interacting with the platform maybe for the next 5 minutes, and then it's going to predict the next interactions. Now, I like this entire idea. My point is not to only shout out what Netflix did, which I guess is very important and very interesting, but my point is more on how we can think out of the box, and rather than just taking a large language model like ChatGPT, Cloud, or whatever, Gemini, and apply that to every single problem that we see in our own niche, in our own kind of environment, we can be a little bit more innovative and maybe come up with a new way of tokenizing things, maybe come up with a new alphabet related to our work, and then try to come up with our own models, very specific models that are going to beat any other model in this specific family of tasks that we are interested in. And this one really reminded me of another paper that I believe we discussed maybe 2 or 3 meetings ago that kind of did the same thing by looking at the different events that happen to patients when they come to an hospital from the time that they get admitted in the ED, every single lab that is ordered for them, every single bed changes that happen, for example, when they move from the ED to the floors, and then the different diagnoses they receive, the different tests they go through, the different treatments they receive. And they thought that, okay, this itself is also kind of a language, right? And the words or the alphabets of this language is going to be the events that can happen in the hospital. So if we can code a single patient's journey with this kind of language, make it kind of systematic, make it kind of structured, then we can train an entire foundation model on this corpus of new sentences, every word in which is going to be an event that happened to a patient. And they trained that, and then they showed that their model is actually very good in predicting what next is going to happen to the patient. For example, if you ask the model that, hey, this patient has come so far, now they are on the floors, now they are going through a CT scan, the model can predict that with respect to everything that it has learned before and the course of the patient so far. Maybe he or she is going to have this diagnosis after the CT scan, or maybe they are going to have a contrast reaction, God forbid, in the CT scan. So I guess this entire school of thought that we don't need to confine ourselves to the alphabet-like kind of language is very valuable, and something that both Netflix proved in this blog post and that paper we discussed already proved in their work. And I'm curious to hear your thoughts on that, Moein, as well.
Yeah, thanks for sharing this. It was very mind-opening idea that you're just not bound to the tools that are already available in another area, like the tokenization that you are used to in the natural language. And you can basically come up with your own tokenization that serves you best. When you were introducing this idea, I was immediately reminded of the new paper by 2 senior DeepMind researchers, one DeepMind researcher, another one from Canada, on the era of experience. By the paper is by DeepMind, and I can share it. It made lots of hype when it came out, and I think it really deserved that. And that's it. It wasn't on my list, so I didn't went.
Sure. Yeah, that's okay. Let's just.
Are you seeing the share the screen?
Not yet. I do see the highlight this PDF icon on the top right, but not the actual. Oh yeah, now there we go. Now I have the.
This is title is "Welcome to the Era of Experience," and by 2 very well-known researchers, David Silver and Richard Sutton. Richard Sutton is the a winner of the Turing Award for this year, and David Silver is one of the main contributors to the most of the DeepMind papers from AlphaZero, AlphaGo, and is a professor at, I think, Oxford and DeepMind, if I'm not mistaken, and he's a big expert in the reinforcement learning field. And what I remember from this, and what got reminded when you were introducing that example, is that, okay, we now know that reinforcement learning works. We now know that, by the examples of these latest models like DeepSeek, and how the latest models, LLMs by Google and OpenAI are being trained. The O3 models, as we know, are RL plays a big role there. And we also know that an architecture called transformer and a method of training called autoregressive training, which is basically all of the models in this scene are trained with transformer, autoregressive training, and gradient descent, are the main components that are working very well these days. The problem is that the data is static, and the data is coming from the human interactions that have happened in the internet and the text that is available or the images that is available, and that is limiting the performance of these models. And it's an unfair kind of comparison to how humans learn, because we humans get lots of signals from the environments we live in, and by the choices we make, by the feedbacks we get from the environment, not immediately like these LLMs do. I mean, when they interact with the human user, the feedback that they get is very immediate and very short-sighted for an interaction of maybe a few minutes. And even if that data is being used to retrain those models, that feedback is not very helpful to the model to train it on the complicated cases that can come up. Like we humans are being trained by the decisions we've made probably 6 years ago, and we see the outcomes these days. So these are basically training our brain natural neurons. But for these models, the feedbacks are very, very limited and local, basically not in a global case. But what the main point I wanted to mention here was that the main thing that is going to help these models become much better at what they are doing these days is to deploy them in the environments that finally they will be working in. And this example that you said, that the model is now seeing or being trained on every single action that a human is doing, it's like tokenizing the environment with the language of that foundation model. And these people were also proposing that we need to have models in their real environments. I mean, they don't necessarily mean physical environments and make robots, but having models, software that are being run on the internet for a longer time, that are independent, that they can make decisions and they can see the outcomes of their decisions, and they can interact with the environment, and they can see and receive all the sorts of signals and inputs that the environment can provide to them. And in that case, these models will be much more generalizable to future situations. And it's much better than kind of like a simulation of what happened via text or via some other forms of compressive method for tokenizing these events. And this was just something that came to my mind. I think it was also good that we mentioned this paper. It came, I think, 2 weeks ago, and it's a really good read. To be honest, I just read a summary of that when I was on a night shift, but it was on my list to go deeper into and see what are the other ideas that they have mentioned.
Very nice paper, thank you. And it kind of it really makes sense. You know, the more that you move away from the limitations we as humans imposed to these large language models and have them, you know, just grasp the insights on their own without us necessarily feature engineering them, which not always result in a better result. That would be very valuable, and that could actually open doors to much higher performance levels seen from those models. And I guess, I don't know who said that, but I believe that, you know, the next big checkpoint for these models would happen when we can safely train them on videos of what is happening in this world. Because if you just show them whatever that is happening, and then, you know, not just for the sake of training a video foundation model that is going to predict the next slice, but basically by just having them figure out the language from what people are saying, so that this time instead of just looking at the words, they also look at the facial expression of the person saying that, the environment that they are in, the kind of community that they have built around themselves. Then those insights are going to be much heavier. And probably even better than that is going to be the time when when our robotic science comes to a point that we can give those models some artificial tools to experience this world on their own, interact with that, interact with others, and then come up with their own kind of understanding of the world as well. Very interesting ideas. Not sure how long we still have to reach there, but very interesting to wait for it.
Yeah, definitely. So you can take it on and
Well,
introduce like topics
yeah, I
that you
think
had.
I think this would be the last one that I want to show things. I have a couple of things that I can very quickly share with you. Neither of those are going to take as long as the previous topics I mentioned took, but it's still worth mentioning here. So let me share again. So a couple of things. The first thing I wanted to mention is this new course by deeplearning.ai. I guess every time that we speak together, we usually introduce one of these courses. This one is also a nice one. It's still on my list to go through, but I took a look at the feedback that people gave to the course on social media, and that was very nice. So this is from the developers of smolagents. So smolagents is actually a framework, a Pythonish framework from Hugging Face team that is supposed to help you with putting together multi-agent frameworks. And what fundamentally makes it different from the other kind of frameworks that we already know, like Crew AI and others, is that the smolagents builds agents that express what they want to do by codes rather than by just returning a structured output in a JSON format. And I guess that is an interesting idea. And I believe, as the smolagent team has been advocating about that, it can result in more consistent behavior. Yet still, it is a good idea to just go through this not very long course. I guess the entire course, if you just sum all these videos together, is going to be about half an hour. So it's a nice watch, maybe a short watch, to understand how this package works and if it is worth for people watching us to explore that in their projects. So that's one small course to mention here. The other one is this nice paper that I ran into, which is surprisingly not about large language models, but about diffusion models that we hear less and less about as we go forward. But from every now and then we just find a very interesting paper in that realm as well. And this is regarding video generation using diffusion models. The thing that made me really pick this paper was that these authors were, by the way, from Stanford. They basically came up with a nice schema for fitting different frames on GPU. So this is not the regular kind of model that we might train, and we basically just rely on the simple functionalities that PyTorch has to offer. They basically did some tricks and tweaks to how the data is going to fit into the GPUs so that they can train and infer a video diffusion model on just a user level kind of GPU like RTX 4090 with a speed of 2.5 seconds per frame, which I guess is very nice. And even if you optimize that, it's going to be 1.5 seconds per frame. And this is something very nice. So it's video diffusion, but feels like image diffusion. So the idea is very similar to the video diffusion models that we know from before. So still, you are going to condition your model on some prior frames and task it to generate the upcoming frames for you. This is no surprise. The thing is that they are going to fit those frames on a GPU core similar to how this diagram shows. I mean, they basically are going to give different relational spaces, or token counts to every frame. And as we go further in the future, the number of tokens that a frame receives on the memory is going to be less and less. So, for example, if we go past far away, if we are moving past in time, so the frame that we immediately saw is going to be the most prominent contributing factor to the frame that is going to generate, and then frames beforehand are going to receive less and less number of tokens. And then this way, the model is going to be able to basically process all these tokens very fast, because not all your frames are going to have similar number of tokens in the memory. And then the entire setup is going to become very memory efficient. Now, they talk about some tweaks and how they basically are coming up with different schemas for different scenarios, for handling different types of videos. But this is the main message, and they show that they can easily come up with very nice videos and very realistic videos out of one image or out of a video. And you're seeing examples of how their models resulted. And again, very interesting to mention that all of these are computed by RTX 3060 6 GB laptop with 13 billion HY variant. I'm not quite sure what HY stands for here, probably maybe part of their model, but anyhow, so they are doing something very nice. And as you see here, they can basically come up with a video for these static images in a very nice way. So I would say this is a very interesting work, and I guess this opens doors to running these huge diffusion models on consumer level laptops or consumer level compute. And I just wanted to mention this paper, and I believe they also open source their codes, so people can go through this and look at their diffusers and see how they have done that. Another interesting paper to just have on.
Yeah, this is one of those papers and technologies that just probably will import in your code and use it, and you don't want to know what is happening behind the scenes.
Exactly. You don't want to see what is happening behind the scenes.
Super complicated.
Yeah.
And it will ruin your confidence that you have in your analyst skills.
Yeah, I was trying to see if they actually did any CUDA level tuning. I didn't see that, but I'm pretty much sure that they are messing up with the GPU here. This is not the regular
I think definitely they've done something at the level of CUDA level programming that is very kind of like something very nice to have at these days, because I think most of the improvements in the training scripts and those sorts of things are happening at that scale these days at OpenAI and DeepMind, and very few people have those kinds of skills.
Exactly. This is a very interesting paper. I really like that, and I guess the blog post also is very concise, so people can just come and review that. So that is this. Then I believe I just have a nice Colab notebook or GitHub notebook to share with everyone. This is from Dr. Shang Zhu. I believe he's also from Stanford. In this notebook, he's trying to basically build a deep research framework for you using some simple APIs. And I believe he's just using the Together API, which is an online provider for LLMs, and a search engine kind of API. And he's showing you how you can basically come up with a deep research framework on your own, even if you are not willing to use the ones that are provided out of the box from commercial providers. You can actually come up with something that is doing the same thing, probably with a little bit less quality if you don't optimize it that well, but it still does the job for you. And this is a very nice notebook, very nicely commented out, very nicely explained everything. So if you want to just see how this kind of system could be built from scratch, and maybe just give yourself some fun time playing out with LLMs, just go and find this notebook and play with that a little bit. It is on Together Cook, which is the GitHub for Together AI, and then you can just easily find this. I guess you just need 2 APIs, and with a little bit of payment, you can recreate this entire notebook for yourself.
Thanks for introducing this. Definitely helpful.
Yeah, that's fun. Okay. Nice fun. Yeah, and then the 2 last one, Moein. One is, let me start with this one. This is Duckling. Duckling is a nice package that is built for processing PDF or basically any kind of document types that you and I deal with every day, like Word files, PDF, Excel files, HTML, images, everything. And they can parse all of that for you using some models that they have internally. And I believe all those models are kind of borrowed from Hugging Face, so you don't need to pay as far as you have to compute. And the compute, I don't think, is that long. I believe I just closed the Google Colab notebook that I had open, but on a very simple Colab notebook without even enabling any GPU, you can just give this package a few minutes, and then it will basically convert a full archive manuscript as a PDF to a very nice processed markdown file. I know that we have many of these packages available nowadays. So now the question is more of what package can be the most cost efficient and what package is going to be the easiest to work with. And Duckling, I believe, is not that difficult to work with. I still find their documentation a little bit incomplete. They could come up with better examples. But at least you have access to the source code. And nowadays we have lots of these LLM-based toolboxes that could basically parse the entire GitHub for you and let you know what is happening there. And they have received an enormous amount of stars, 28,000, lots of forks. And I believe that if you go to the issues, you will probably find answers to many of the questions. They also have, as I said, a relatively comprehensive documentation with some caveats here and there, but something free to work with. And I guess they have also nice integrations with some packages like LangChain and Crew AI. So if people work with those, they might even use this package internally and work with that. So Duckling is something to have on our radar in case that we want to come up with projects that is processing some documentations. And my last one, this is Seema Studio. I'm not sure if you heard about that, Moein, or not, but Seema Studio was an AI startup I read about a few days ago. And
that
this
is the workflow that's I think you can just connect agents together and then
exactly. This is exactly what it sounds, right? It's a no code or low code, because I also played with their platform a little bit. You still can, there are lots of things that the developers know how to do on their platform and probably not regular users, but it's still a relatively no code framework for building and deploying agentic workflows and multi-agentic workflows. And I guess this first diagram clearly shows what is happening. So you can come up with a function. As you see here, you can write your own JS code here, and then you have an agent. You can give it a user prompt. You can simply choose the model you want this agent to work based on, and then give it some tools. And then you have some routers that can connect this agent to some other channels or multimedia, and then have it work. And this is a nice one. I didn't spend that much of time, but at least I put my email on their wait list, and now I have access to how these things works. So say, for example, I want to create an agent here. I can just, this is just giving you the capability to come up with your own workflow. So a start workflow here can run manually on webhook call or on a schedule, depending on who you like. And then maybe the first agent can do something. You can add lots of tools to that. So let's see if I can maybe come down so that you can see the list of tools here. The agents can have browser use kind of tools, to fire crawl for crawling the web page, GitHub, Gmail, Google Docs, a lot of things. And even can connect to many different platforms. And then you can put a router here and maybe connect it to some, I don't know, anything. We can basically, I'm not sure if it's going to connect like this to this, or maybe like this. Yeah, you can just connect, I guess, agents and routers together like that. Maybe I'm not doing that in the wrong way, but anyhow, so you can have routers, and routers are, again, LLMs that can basically now split the workflow into different pathways. And then you can also have conditions. Conditions are scripts that you can like here. So this is JavaScript code. So depending on what your models, what your agents are returning back, you could basically have conditions, and maybe a router could be connected to that condition. And then you can also have APIs. And APIs are just basically URLs, query parameters, headers. So basically you can receive, you can just query an API, fetch the JSON that is coming out of that, and then based on the API results, move your workflows towards one path or another. So kind of a nice workflow. I'm still looking to see some real use cases coming out of that, but I guess the simple fact that there is such a clean UI for doing things like this is very interesting. And that would be just a matter of time until people actually start doing meaningful tasks with this, but something to have an eye on. And I guess I've not paid anything. So if you just go to their webpage and put your email on their wait list, I believe after a few days, you should be able to work with this one as well. So quite a nice UI.
Yeah, it was very interesting to see this in action, because it was something that I remember you were ideating about and even working towards making.
Yeah,
And yeah, it's fun to see this being in action. And yeah, as you said, we need to probably wait to see the real use cases that people will come up with. And I think
exactly.
this will probably be something that maybe OpenAI and Google will provide someday soon
Yeah,
on their platforms, because they own the
yeah,
LLMs.
yeah,
And for probably something that is more developer facing feature, uh, and I think there many of the simple applications that come to mind, that I want some simple tool to do X and Y, to just grab some info from there and put it there.
yeah,
These sorts of agentic frameworks is very good at those kind of automation for pipelines
yeah,
that people want to add to their routines. Yeah.
yeah. And I also wanted to show the subscription plans that they have. So it's very similar to the other kind of providers that we see nowadays. So $20 is going to be the pro tier, probably the one that people are going to work with. And I'm not quite sure how do the inference credits count here and how much of inference credits you are going to spend for different tasks that your model does. But basically, whenever you have your fully functioning workflow, the thing is that you can deploy it as an API. So the output of this Sim Studio is going to be an online API that they are going to host on their own. So later on, you can connect your different workflows to this API as well. So it's a kind of a nice one. I mean, if it certainly needs a specific use cases. It's not something that you and I can come to and play with every day just for the sake of fun of it. But if you have a use case in mind, then I believe, and you don't want to spend too much time on building something using code on your own, this still can help you to just maybe quickly try something out and then go and see it in action and see how it is working. Probably will really accelerate experimentation.
Yeah, I agree.
All right, so that was the last item on my list to share today, Moein. So I'm going to stop and I will listen to any ideas that you have to share, and then afterward we can wrap up the session.
Sure. I also have a few quick mentions,
Yeah.
blogs and yeah, mostly blogs basically, and papers.
Okay.
And let me start from here. The first one is this interesting paper, uh, uh, Calibrating Expressions of Certainty.
Mm.
And this is a very technical work, but on a medical topic. And that is calibrating the expressions of certainty in radiology reports. Like, as we know, the radiologists and use lots of words like likely, most probably, or indicative of. That's they use in the reports to imply that some diagnosis could be considered for this case. And the authors argue that these words are not very, I mean, they're not calibrated
Mhm.
appropriately, and different people can mean different things by them. So it's good to come up with a framework that um, calibrates these expressions. And they say that, okay, it doesn't make sense to just give a number to each of these expressions. Like if they say most likely it's 80%, if they say likely it's 70%. So they came up with a distribution for each of these words. And this is
Mhm.
really interesting, that they're applying um, uh, mathematical distributions to these words, and how they're applied and how they're used in the context of radiology reports. The final outcomes of the paper, just to show that this is a very technical paper, lots of math is involved. I'm sharing this paper, and this is presented at ICLR 2025, which
Mhm.
was held just a few days back in Singapore. And they finally came up with some distributions for each of these terms that is shown in the appendix. But one figure here, which is from an earlier work, they improved on this one, is this figure here. which shows that the probability density functions obtained by fitting meta distributions to the results of a survey of radiologists' perception of different certainty phrases. And as you can see, this is one of the works in the literature around making distributions of probability around these expressions. They go on and introduce some novel techniques how to improve on this and how to calibrate or how to change some phrases to make the reports more calibrated with the final diagnosis of those patients. And there is an accompanying blog post in the MIT News, which is much easier to read, free of any difficult math. And the first example here is very interesting, and it's that if the report for this image has been something like possible pneumonia, the following order would be just some follow-up CT, and there wouldn't be an immediate treatment ordered by the physicians reading that report. But if the impression just is slightly changed to likely pneumonia, the next step would be prescribing antibiotics and order CT. And this is based on some historic examples in their data sets that they saw this. But possible and likely aren't that different in terms of just the language being used. But they have very different outcomes. So it's better that the level of certainty of the physician or the radiologist writing that report is calibrated to the final consequence of that expression. And I just go through my highlights from a few weeks back. And the cool thing that they show is that when radiologists express confidence about a certain pathology using a phrase like very likely, they tend to be overconfident, and the vice versa is also applicable in the same scenario. And just another point here is that this is from the first example. If just the possible is changed to likely, the whole next steps will be changed. And here they argue that it doesn't make sense to just give fixed numbers to expressions, and distributions of probability make much more sense in this case. And
that's a very interesting paper, Moein. Very, very interesting one.
Yeah, I really like the idea they were presenting, and the fact that they weren't just applying this to the models, they went on and applied their final calibrated phrases in terms of comparing the probability density functions, and they changed the reports. They corrected the words that was better be used in that context, and they found that now these changed reports by humans are much more calibrated with the outcomes. So that was a cool thing that was also applicable to the humans.
Yeah,
and not just some method that is going to be used with some models in the future. Yeah.
I mean, that's very, very true, because nobody has taught us, and I don't think that nobody is going to teach these to any radiologist or pathologist or anybody who reports this kind of imaging data to use to be this much of nuanced on the kind of exact word that they're using, likely, possibly. We all just use these words all over the place, and nobody really pays attention to what is these words suggesting to the person reading the report. And this is super interesting, that how calibrating these is going to improve clinical outcomes. I really like that. Really, really like that. Very interesting paper.
And also this paragraph here is also interesting. They found that the radiologists were generally underconfident when diagnosing common conditions like atelectasis, but overconfident with more ambiguous conditions like infection. So this is a huge source of being miscalibrated. The radiologist's brain as a kind of a model to the outcomes, to the true outcomes that is happening in the environment. And I really like that as we go through the research of AI, the methods are not making much distinctions between how the human brain is working and how these LLMs are working.
Yep.
We are basically converging to some methods that are applicable to both human minds and the artificial models. And I think that is just how the future was
It's
going
going
to
to
look
be
like. And
yeah.
so this was one paper. Another one is a report, the yearly report by Stanford, the AI index report, which is a very comprehensive report on many aspects of AI, both in the health, in the business side, even in the politics. But the part on biology and medicine is a very good read, and I really encourage the audience to go through the report. It is a comprehensive one. There is a whole big chapter on the AI applications in biology and medicine, and I was shocked to see so many money-making applications in biology regarding proteins and
Mhm.
protein structure and sequencing. It is one of the biggest applications of AI in the biology, and I wasn't following that field much, but I think it makes much more sense to follow that field as well, because um, such a successful application, probably there are lots of new and creative techniques that could be applied, that could be used and borrowed from that field and applied to other sources, like what happened to NLP, and then we are seeing in the vision and everywhere basically. So and there are some top takeaways. I'm just skipping this for the sake of time,
Mhm.
because there are not much to discuss. Just the charts are very informative, and I'm going to skip this for now. The other one was this cool initiative by vLLM and Hugging Face, that you can now deploy any Hugging Face language model with vLLM's speed. vLLM is a library that is efficient for deploying and using LLMs and VLMs basically on local machines. So if there is an LLM, open source LLM, that is available on Hugging Face, and you want to run it on your own server or on your own machine efficiently, that is manageable on a maybe single GPU or a machine without GPU with limited resources, vLLM is a good choice. And now any model on Hugging Face could be deployed using this library, which is, I think, a big move by their teams.
Mhm. Moein, I never worked with vLLM. Is that similar to Ollama in terms of functionality?
It is more developer faced and more dependent on the codes that you need to write around your model.
Okay.
So it is basically that, it is assuming that a developer is going to use a model in a code, but they don't want to go deep down on making it efficient and making it deployable
Okay.
along other scripts. So they import this their model with the wrapper of vLLM, and it's basically happening in the environment of the Python coding,
Okay.
not in the
So
terminal.
you
Yes.
don't need to basically have the model to read an API coming out of your system. It's basically all happening in your own code, because that's how
Yeah.
all works.
Yeah, the examples I have seen, I haven't worked with it on a
Mhm.
personal project, but the tutorials and the blog post that they released that I was studying for this topic, they were like, yeah, you import a model from Hugging Face, you put it in a wrapper from vLLM, and then you can call it in your Python script much more faster, much more manageable and scalable when lots of API calls are coming into your application, like a Flask application or Django application. So yeah, this was something interesting and I think useful. The other one that I just go through the main figure here. It was a very interesting report by Harvard Business Review about how people are really using generative AI in 2025. And this figure here is it was very shocking to me and very informative. And it's showing that the use cases of the LLMs, it is mostly about chatbots like ChatGPT and Gemini. In their surveys from 2024 to 2025 has changed a lot. And these days, the most common application that people, these are not just only technical people, people in general, are using these LLMs for is for therapy and companionship, which is very interesting.
Yeah.
And this is something that I really didn't expect, that people use these LLMs as a companion, as a friend, maybe as a therapist. And it is in contrast with the last year's trend, which was basically for generating ideas. And in the technical space, it was for maybe writing code, debugging something, or explaining how this code works. And I think this maybe relates to the early adopters of the ChatGPT and these kinds of technology, where that were mostly first developers themselves, and the use cases were the use cases of developers in those days. But these days, everyone is basically using these tools. So it's not going to be limited to just some coding use cases or technical things in general. And the second most common application is to organize my life and finding purpose. And the enhanced learning is much higher in the ranking from last year, from 8th to 4th ranking. And yeah, the generating code here and then generating ideas is 6 now from being first on last year. And yeah, this was another unexpected finding about how LLMs are being used these days. Yeah, and it goes into very examples and anecdotal kind of like facts about how people are using this. For example, for the therapist, it mentions one of the respondents that yeah, it makes total sense to use ChatGPT as your therapy. I mean, that person was saying because therapy is much more expensive. There are not many therapists available everywhere. Here, you can just go in conversation with someone who maybe understands you 24/7. That is much more manageable in terms of cost, even being free. And that was some source of reasoning that people were saying on why they're using this as their therapist. And yeah.
And Moein, I
Yes.
remember that I unfortunately didn't put the paper on my list for today, but I saw a paper a couple of days ago that was actually offering a very nice multi-agent framework for acting like your therapy, acting like your psychologist. And it was like an agent who can empathize with the patient, do the actual interview, an agent behind the scene who synthesizes the evidence and collects all the different signs and symptoms that the other agent collected, and then one who judges and makes a decision, and then the last one who actually comes up with some sort of recommendations or even refer the patient to a real doctor. And that was super interesting. Unfortunately, I didn't know why I forgot to put that on my list, but maybe I find it and put it on our discussion list for the next session. But you actually reminded me of that one. This is a very, very cool diagram. And I'm very happy that you showed this. It's very insightful.
Yeah, and thanks for introducing that idea. And just for the audience that might be listening this, just wanted to say that one of the shortcomings or challenges with these LLMs these days is that they're very agreeable with whatever you say. That is not maybe a good idea to go therapy with one of these LLMs.
Definitely.
And you still need to check that, and maybe at least that agenting framework makes much more sense, because there is a third or maybe fourth agent or LLM that is overseeing this whole process and can pick up the signals that are, yeah, the first LLM is just agreeing with whatever the person is saying, maybe that's not right. And this process needs to be reinforced, because in therapy, you don't often hear what you wanted to hear. You're just shown some facts about your thinking that is very hard to get out of these LLMs, which their whole business is around making you happy with their whatever they say. So this is something just to keep in mind. But I'm sure that these technology will play a big role in the mental health of the people in the next coming years. We just need to find out how we can safely adopt them.
Yeah, I mean, I really appreciate you mentioning that warning, and that's a very, very true warning, not only with respect to these LLMs being used for therapy or anything related to psychology use cases, but also for physiologic use cases, general healthcare recommendations as well. I mean, most of these commercial LLMs do have some guardrails that will probably show users some warning on, don't use our recommendations for actual healthcare scenarios. But still, there are many, many different ways that you can bypass those guardrails. You can just force an LLM to tell you what you like to hear, but what you like to hear is not necessarily what you really need. So in case of, I mean, despite whatever we are saying, despite whatever that might these LLMs or AI in general does in future for the sake of healthcare, we are not yet there. So we are not yet at the point that we can expect a large language model to independently take care of our health and take care of our mental health. So please don't do that to yourself. I mean, this is just for the sake of ideation of what is yet to come, but we are not yet there.
Yeah. So I will be quick from here to
Mhm.
introduce the other ones. There's maybe one other topic or two that is remaining. And this was this cool blog post by Simon Willison, who I mentioned in the previous episode as well. Uh, and the title is "Watching O3 Guess a Photo's Location is Surreal, Dystopian, and Wildly Entertaining." And the story is that Simon uploads this picture to this O3 model that was recently released. And as the audience may know from the introductory blog posts and videos of O3, is that now O3 can reason in the images, so it can crop some part of image and zoom in and get more information out of it. And all of this is being done automatically and using Python and tools in the background. And the question is, can it guess the location, the exact location, or maybe the county, the streets, by just uploading this photo, which doesn't have much landmark in it? And as it turns out, the model is able to guess close to the street that the patient is standing. And there are some images that it shows. It zooms in to read the plate number, and it sees that, okay, it looks like the plates in the California state. And then it gets something out of the climate and the kind of I'm not sure how to put it, the
Yeah.
trees, the grass in the background, and see where do these trees kind of like are planted and where do they grow. And the when you go through the thinking of the model, is really kind of like a sci-fi movie that is just getting whatever it can from those pixels, and it finally comes up with the right answer. So yeah, that was also another interesting thing that is doable these days with these new models. The other one was, I think, something related to this, if I can find it. Mm, yes, related to this one was this conversation here, this thread of conversation on Twitter that happened. One PhD student mentioned their work that was, uh, uh, she was claiming that the new capability in the O3 model, which is reasoning through the images, is like the idea that they had introduced in some earlier paper. And then there were some argue about OpenAI not mentioning the sources that they have used. But one of the members of the O3 team from OpenAI came and said, we didn't basically force anything to this model, and the model came up with this approach to use Python in the background and crop the images and zoom in and get more information just by applying RL and reasoning, and which
Yeah.
was something I think unexpected to happen, just by uh, putting model on without putting any limits on the model and giving it access to some tools. It would be able to do these creative ways of gathering information and to reason, basically.
Yeah. I
And yeah, I think, yeah, my list finishes here. These were the topics I wanted to introduce, and
think
I
ones.
really enjoyed this conversation. I learned
Me
a lot. lots of new tools and topics to dive deeper into afterwards. So yeah.
Thank you, Moein. Thank you. I also really enjoyed this session, like previous sessions as well. I mean, every time that we speak to each other, I put together a list of items to go through and read them. The thing is that as soon as I want to go through even not half of that list, many more items come and receive more priority on my list. So I'm still not sure how to handle staying on top of things. But this is one of the sweetest concerns that we can have in our lives, to be ready to learn many new things and to have many new things to learn, yet still be out of time for doing so. So this is the kind of concern that I would like to have instead of many other concerns in my life. But anyhow, thank you very much for this roughly 2 hours that we have spent together, and thank you to everyone who were listening to us and watching us. Moein, I'm not quite sure what will happen if I stop recording now and we continue the meeting. So probably it might be worth to just discontinue the meeting as a whole and make sure that the video is being saved for this first time. And hopefully this new Google Meet-based kind of recording is also going to improve our quality on YouTube, and see if we want to stick with that or not.
Yeah, I hope so. And thank you for your time. I really enjoyed it. And yeah, so
thank you. Yep.
We can stop here.
Let's call it today. Goodbye. Have a good day.
Have a good day. Goodbye.
Goodbye.